In this video, we're going to start focusing in on a quantitative variable and how we can describe and summarize that variable. In previous videos, we've worked with the qualitative variable and we've built a frequency table and then a bar chart and pie charts to visualize that frequency table or relative frequency table information. Here we're going to use the frequency distribution for the quantitative variable. The quantitative variable we're going to focus in on is annual income, and this is coming from that larger made-up data that we've been using. So when we turn to this quantitative data, again, we're going to use the frequency distribution, and as we've talked about, that's going to look almost identical. It's going to be built almost identical to the frequency table. There's just some slight some extra steps we need to take along the way. This is largely because, remember with the frequency table, we had some of the decisions made for us. So the classes that we used were just the types of states or the states that were in our state variable. Here with the frequency distribution, we need to figure out what we want to use to break the data up, and we're going to refer to these as bins, but they're taking the place of the classes as previous. So let's build let's call it annual income frequency distribution. That's long. Maybe we'll just merge all of those. And we'll just make it bold, stand out a little bit more. Can even underline it so it all looks the same. Okay, so in this case, instead of state, I'm going to keep it a little more general and just say bin. I'm going to add in a little bit more. So I'm going to add in something. I'm going to call it bin upper, and I'll talk about why I'm putting that in there in a second. We'll do frequency, and we'll just prepare for the relative frequency to build that relative frequency distribution. So when we think about bins, we need to make a couple decisions. The first being how many, and then the second being where those bins exactly fall. And so we have a rule of thumb. Remember that rule of thumb is how many bins do we need? Well, we want 2 raised to the power k to be greater than n. Right? And remember, n is our number of observations. So in this data set, we have let's see, it goes down to 31, starts at 2, so we have 30. So we need 2 raised to the k to be greater than 30. And so, again, that means 2 to the power 5 is going to make it work, right? So 2 to the 5th is equal to 32, which is greater than 30. And so we want 5 bins. And I've mentioned before, but this is kind of it's a starting point. So we want to remain a little flexible. There's going to be times where it makes a little more sense to actually stretch that to 6 or cut it back to 4. But this is a good rule of thumb to get us in the right ballpark. So we're going to go with that. We're going to try to make 5 bins. Now, where do we want them to be? Well, remember, we need to make sure that our bins stretch the entire length of our data, because we want to make sure that it is collectively exhaustive, right? We need to make sure every observation here has a home in one of the bins. So for instance, if our bins stop at 100,000, then these numbers that are above 100,000 aren't going to have a home. So we've failed the collectively exhaustive. So one way to help us along that process, and you can see I've already have it written out here, but I've put in the max. So I've used the max formula, equals max, and then selected the data. And that's going to give me the maximum value in this range that I've selected. And I can do the same thing for minimum. And so then I have found both the max and the min. So now right away I know that I need the bins to stretch below 21.8 and above 114.8. I've also calculated the range, which is just the difference between that max and that min. Okay, so I know that it needs to stretch at least 93 if I'm going to cover both of those ends. And so what I'll probably do is round that up to 100, knowing that I need 5 bins. That makes it pretty easy to divide, making them 20. So this is actually pretty straightforward. There's not a lot of decisions to make. And again, so now I want to make 5 bins of size 20, and I know I need to be below 21.8, so pretty natural to start it at the nice round 20. So I'm going to have bins ranging from 20 to 40, 40 to 60, 60 to 80, 80 to 100, and 100 to 120. Now, we do need to make a little more. We need to make another decision here, right? So we've already talked about collectively exhaustive. We need our bins to be mutually exclusive as well. So right now, the way I have it listed out, what if I had a value exactly at 40? Well, we wouldn't actually know which bin this goes in. So we are going to need to be more specific about that and define which one gets the 40 and which one doesn't. So bear that in mind, and we'll code that in as we tell Excel what to exactly look for. I'm going to go ahead and just give an upper end of the bin, and we'll talk about more why I'm doing that here in a second when we get to actually having Excel start counting. So if you recall, back in the frequency table, we used the COUNTIF statement. And we're going to do something similar, except this time we're going to use COUNTIFs with an S on the end. And that's because it allows us to give more than one criteria. So I'm gonna jump in and just show you the formula, and we'll use COUNTIFs, and then notice it now it says criteria range 1. So this is going to allow us to do, actually you can do many criteria, but we'll just do 2 criteria. And so we are going to we're going to have Excel look over the range that we want to count and count up how many times it satisfies both criterias. So it may make more sense once we have got one on the board. So the criteria range, the first range, is going to be over our data. Okay, and then what criteria are we wanting? Well, we want a so I'm working in the 40 to 60 bin. So we would like these values to be greater than. So I'm going to put this in quotations, greater than or equal to 40. Okay, and so that's gonna look across this this range and decide if that's greater than or equal to 40. And then my second criteria is going to be over the same range, and then the criteria is going to be less than. So I'm going to put that in quotes as well, less than 60. Okay, so here I've made that decision that the upper bound is not actually included in this bin. Okay, so when I hit enter here, I see that this has happened 5 times. So again, this is looking over this range and it's counting up how many times it's both greater than 40 and less than 60. And it should be more clear, greater than or equal to 40 and less than 60. So when we, whoops, I don't want to do that. So we can keep doing this here, and one handy way to do that. So I'm going to lock in the range here. I don't want that to move. Okay, this just takes a little tedious. So now when I drag it down, it's going to do the same value, but I can go in and just directly change these numbers. Okay, and we see there's 9 there. And see, I wanted that as 100 to 120. And then up here, we can do the same thing. We don't actually have to have that lower bound. We could take that away. We could just do a count if there. We don't. Whoop. Just to clean up things, we don't really want those decimal points. It'll be cleaner without them. And then I'm going to go ahead and do a equals sum and count up all of these. Okay, so we'll do a little, we'll just indicate that that's the sum, and knowing that that's 30, that checks out. That's what we expected. We can set that apart a little bit just to help our eyes. And there we have it. We have a frequency distribution for the annual income. And again, the relative frequency distribution, just like the relative frequency table, it follows directly from the frequency distribution. So I'm going to go ahead and lock that in, right? So I want to lock in the L10, which is going to let me drag this down while still changing the from L6 to L7 and so on. This is, again, we'll go in here and we'll format the cells, put it into a number here with 2 might be okay. We're probably not too particular there. And then I'm going to go ahead and I'm going to drag this over. That's going to sum that up and it better equal 100, and it does. So 100% is accounted for. And so now we know we can look at the frequency and relative frequency of how often our sales, our annual income falls into these various bins. And so that's the way we go ahead and build frequency and relative frequency distributions in Excel.